So let's look at the Sapiens decision suite. The suite consists of DM, where business logic is modeled. That's our decision modeler. DX, which exports the DM logic into executable form, into multiple different rules engines. DE is our own optional execution engine. And DI, which is what I'm going to talk about, is our data virtualization tool. It begins with the modeling of a decision to be deployed into the execution environment. And that defines really the glossary that we're going to be using. It's that glossary that we want to turn into some input, derive that input from some data form in multiple different data sources. So what DI does for us is it takes that logical unit of data, that logical unit of input that we want, forms it into this logical unit, and allows us to map that logical unit to multiple different data sources. It does transformation on those data sources. It enables us to do whatever enrichment we need to do on those data sources, but it maintains the integrity of the logical unit at all times, and then allows us to capture not only the inputs that's going into this data, but also to capture the outputs, so that we can form some sort of transactional history of what went into the decision, what came out of the decision, and I'll talk about the value of that. And then we persist all of that input and output in the process. So that's kind of the process I'm going to demonstrate to you today in our tool, and I'm going to talk about the value that that brings in our tool. So a logical unit is the critical factor to understand. So what is a logical unit? It's the business-oriented data. It is a unit of data, and each logical unit is an instance, a self-contained database, a micro-database, the keys, the indexes, everything together. So in the traditional BDMS, RDBMS structure, we had all these different applications with their different databases. Unstructured big data gives us this massive data we have to traverse to get any value out of. In a logical unit, we keep that data in this small micro database that is entity related, business entity related, and we synchronize the sources of that data into that logical unit for when we need that logical unit. We can also create row-level security. Actually, the security we provide is 3 levels. Each unit of data, each entity is secured by 3 levels of security. It's extremely difficult to break. The architecture is very simple. We have web and database services that provide the interface into the engine. So we can expose those services. We have an authentication engine and encryption engine that provides that level of encryption that I talked about. The engine also provides a masking capability so that you can create test data sources for it. It has a processing engine that actually takes the data from the interface, manages it through the distributed workers in the distributed database, and then fetches the data from the smart data controller. Smart data controller is what talks to the external ETL sources. The tool has a built-in ETL capability. And so the architecture is very simple. It's a fully distributed database. It's linearly scalable. It's highly available. No single point of failure with embedded replication. It has in-memory computation. The logical unit, because we're only keeping the logical unit in memory at any time, we can do with very small amounts of memory what takes large data, big data, enormous horsepower to manage. We have embedded ETL, embedded web services, SQL support and REST-like APIs, flexible synchronization, and we fully integrated with the decision suite for business orientation. So what's the point of this all? Wow, that was quick. What's the point of this all? The point of it all is not just the blocking and tackling for the data that you need for your integration of your BPM suite. That's not the point of it at all. The point of it all is to actually model our data just as we model our decision models. model our data from a business perspective, and not just model the data, but deliver to our clients the ability to actually build a history of the inputs and the outputs from their decisions so that they can derive real insight from that data. What we mean by insight is, instead of looking at transactional history for our analytics, we're going to be looking at decision history for our analytics. What went into the decision, what was the logic we used, and what were the results we got. We think those kinds of insights are going to become extremely valuable. So let me show you a little bit of the tools. We can start with Sapiens Decision. Sapiens Decision is our decision modeling environment. Some of you may be aware of it. And what I'll do is we'll look at a decision in Sapiens Decision. This is a decision using the TDM, the decision model notation. Some of you may be familiar with it. What you see at the top, the blue octagon, is the decision. Each of these green structures are what we call rule families. They're groups of logic. We can look at that in a DMN format, so you can model. You can actually model in either DMN or TDM format. It's the same model, but this model is interesting. This model is talking about the whether we're going to automatically or manually renew an insurance policy, a short-term insurance, a P&C insurance policy. And policy renewal method, the decision is dependent upon the level of underwriting risk and also something to do with the pricing. Pricing is dependent upon policy discount. Policy underwriting risk depends on two other decisions: insured major ownership change and insured major location change. Now, in order to implement this decision that the business built, we needed some input data, and I'm going to show the input data. So these input data points are actually the considerations that we need to actually determine whether to automatically or manually renew this policy. So here are some of the inputs we need, and they're described in business-friendly language. So at this point, in order to implement this model, we would go ahead and generate from Sapiens the necessary code to go to a rules engine. Could be a rules engine, could be an ODM engine, it could be just plain Java. So what we would do in Sapiens Decision to actually do that is we would go to the community, the folder the space that holds that particular decision, and we'd go to manage releases. We'd choose a release that has actually already been created, and in that release there are already some assets that have been generated, and we're going to actually create out of it a tag, give that tag a name. That tag is simple. And create it, and that tag, there we go, is what we're going to export. I can't actually see much on the screen, but all right, so we'll go ahead and export that tag. Now, when we export the tag, it offers us which environment we want to export to. So we're now exporting the code, and we can export to, in this particular case, we've implemented rules, Java, ODM, but we'll just export it to our own execution environment, to Sapiens' own execution environment. What happens when you export code, from decision? I just want to check that that it's in our queue. Yeah, it's in our queue. So what's happened now is that we've taken that decision that our modeler has created, and we've exported it into our execution environment, and now we have to go and fetch data to actually use to actually make that decision. Well, at this point in time, what's going to happen is we're going to have to find a way to integrate that data. We're going to have to find the mappings to that data, and we actually, in Sapiens Decision, will keep the XPath or whatever other mapping information that you want for each of those input items. The truth of the matter is, though, some of that data is it's very complicated, actually, the transformations and the lineage of that data in order to acquire that data. And that's where the long pole in the tent in implementing many of these projects come in. So what we do with InfoHub is we actually move that along, and we help that along tremendously by creating, automatically instantiating into InfoHub at the time we export that data, that model, that business model, and here they are. Actually, I've created these two models, and this is what actually happened when we did that export. It created this model, and this model is the logical unit that represents that decision that we generated, for which we generated code. Now, we could have generated for multiple decisions. We could have generated for a whole a group of decisions. In this particular case, I generated just for the one decision. But this is the model in its business-friendly terms. What we are able to do now is we're able to hook this model up to multiple different data sources, do whatever we have to do in terms of transformation and any enrichment we have to do to that data, hook it up, and this becomes our logical unit. When we execute those decisions, InfoHub will take care of ensuring that the logical unit is always synchronized at the time we need the data and will provide that data. And that logical unit is always managed in memory, so it's extremely fast. In fact, because we only have to handle that logical unit, the one instance of logical unit at a time in memory, we are an order of magnitude or greater faster than any of the competitive solutions out there. And so what happens is when you define this, so in this particular case, what I've done is I've hooked up to two databases. They both happen to be Oracle because that's all I'm running on my computer, but they could be multiple different sources. We could go to, the tool is capable of looking at unstructured data. It's capable of looking at web logs. It's capable of integrating into multiple different data sources. And we can hook up to those data sources. And in fact, the way you would do that is you would open your schema. You would, and when we create the schema automatically, we create the schema hooked to just actually a dummy population. What we're going to do is we're going to actually populate that dummy population in our demo. And so if we actually go back to our schema, open our schema, we can connect those database objects. Drag them onto the canvas. I'll take the insured from the policy database, and I'll go, already exists. And I'll get the, I don't know how it already exists. I must have dropped it down here somewhere. And I'll get the property database from here. And then what I can do is, once I have them, I can make this my root, set it as root. What I'm doing now is defining this this logical unit, and I want to set the primary key to this guy here, and save that. And now I can actually start hooking it up. And so I go. Now, what I'll do now is go to my baked chicken oven and show you what the schema may look like fully built out. In this particular case, we have this is what the schema would look like. So what we're talking about is this. This is the logical unit. This is the input that you're going to need. This is the output of that same logical unit. And these are the tables from those three source tables that are actually generating the input. And we can actually look at the actual underlying data transformation that we're doing. And this is what it may look like. In this particular case, we're actually transforming one particular input, one particular attribute, and we're doing a regular expression, a find and replace on a regular expression. We can actually, in our studio, we can actually run that transformation and see what it looks like in operation. Why can we not run it? Well, for whatever reason we can't run it. I wonder if my servers died while this thing was standing around. Well, if we could run it, you would see the transformations visually, and the regular expression is actually. But what you're seeing is the transformation. Let me just show only my connected node and blow this up a bit. So you'll see the transformation that took place as simply a regular expression. It transformed the $32,000 to the form I wanted, 32,000. But the tool has got a wide range of expressions. You can build your own. You can build them out of plain Java, so you can add whatever transformation enrichment you want to the data before it's packaged into your logical unit. And then show all nodes, and let me just get me an automatic layout. So once you've done all your transformations and all the data collection that you want to do, you're ready to actually start executing the decisions. And at this point, we can actually go ahead and take this policy database and deploy it to the server. And if the server is up, yep, it's up. And it's deployed to the server. And now what it's done is it's actually built a web service interface to Decision at this point. And we can deploy those web services to the Decision engine. This could be any of the executable environments that I talked about or that's implemented. And we can actually see this, this decision being executed. We can invoke the web service from the studio. And here is the web service, just a simple interface for the web service. The method name is execute policy decision. And I'm going to just use one policy ID 1000 token. So this is the token that the security, this is part of the security structure where we've created a token for each of the LU instances. And when I submit this, it will actually run the decision engine, and there we go, automatic renewal process. So the decision ran, it said this decision for this particular policy is an automatic renewal. If I change my policy ID to one of the other policies, let's see if we get a different result. And once we actually click submit, we get, this one's a manual renewal process, and these are the messages as to why that's a manual renewal process. And of course, what we've done is we've persisted into our logical unit those particular messages together with a conclusion. So that's a very quick demo of how we would package a piece of data, an input data for a decision, and how we would use that in execution. What we find with our clients is that implementing this significantly reduces the project time for their projects and significantly increases their the visibility that their business users have of the data that they're using and managing the data that they're using from a business perspective. So that's the end of the demo.